Hey, welcome! Today we're going to dive into the physics behind some of the coolest, most common magic tricks you see every day. We're going to figure out why your eyes can't always trust what they see, especially when water gets involved. So are you ready to see through the illusion? Let's get into it. I mean, it's a classic, right? You take a perfectly straight pencil, stick it in a glass of water, and bam! Right where it hits the water, it looks like it's completely bent or even snapped in half. So what is the deal with that? So first off, no, you're not imagining it. The pencil is totally fine. Your eyes aren't lying to you exactly, but they are being fooled by this absolutely brilliant optical illusion, and it's one that's happening all around you all the time. And it is not just about pencils. This exact same effect is responsible for a whole bunch of other weird visual stuff. It's why a swimming pool or a pond always looks way shallower than it actually is. It's why a lemon in a glass of water suddenly looks enormous. Or why if you put a thick piece of glass over a book, the words look like they're floating. They're all just different pieces of the same puzzle. Okay, so to solve this whole mystery, we have to get back to basics and talk about a fundamental rule of light. It's a rule we all kind of learn, but it turns out there's this massive exception to it that changes, well, everything. We're usually taught that light travels in a straight line, right? Just picture a laser beam or those rays of sunlight cutting through a cloudy sky. They're perfectly straight lines. And for the most part, that's how we think light moves. But here's the big question. What happens when that straight beam of light hits a boundary? Like when it goes from moving through the air to moving through something totally different, like water. Does it just carry on in that same straight line? And the answer is a huge no, it doesn't. When light crosses that boundary, it actually bends. It changes direction. And this incredible phenomenon has a name, refraction. This right here is the master key to unlocking all those optical mysteries. Just think about that for a second. This one simple idea, that light doesn't travel in the same direction through everything. It just completely flips that simple straight line rule on its head. The path light takes literally depends on the stuff it's traveling through. Okay, that's enough theory for now. Let's actually see this light bending thing happen with our own eyes. It's a super simple experiment you can totally do at home, and honestly, it feels a little bit like magic. All right, here's what you do. Take a coin and put it in the bottom of an empty bowl. Now, step back just far enough so the rim of the bowl completely hides the coin from your view. Got it? Don't move. Now have a friend start pouring water into that bowl. As it fills up, just watch. That coin is going to magically reappear right where it was. So, what's the trick here? Well, before the water, the light bouncing off the coin was traveling in a straight line that was blocked by the bowl's edge. But when you add the water, the light has to travel from the water into the air to get to your eye. And when it crosses that boundary, it bends, arcing right over the rim and straight to you. It's not magic, it's just physics doing its thing. So now that we're armed with this superpower of understanding refraction, we can finally go back and crack the case of the broken pencil. Let's break down exactly what's happening between your eyes and your brain. Okay, this is the key. The light coming from the part of the pencil that's underwater bends as it leaves the water. But here's the thing. Your brain doesn't know about refraction. It just assumes that light always travels in a straight line. So your brain takes that bent ray of light hitting your eye and traces it backwards in a straight line to a place where the pencil isn't. It creates a ghost image, an apparent position that's higher up. That break you see, that's your brain getting tricked by the bend. And once you get that, all the other mysteries just fall into place. The light from the bottom of the pond bends, making it look raised up and shallower. The light from the sides of that lemon bends outward, making it look magnified. It's all just refraction, plain and simple. So we figured out how light bends, but honestly, that's just the tip of the iceberg. If you start to ask what light is on a fundamental level, oh man, the story gets a whole lot weirder. Thinking of light as just a simple ray is helpful, but it's not even close to the whole story. For centuries, scientists were completely stumped by this because sometimes light acts exactly like a wave, spreading out, bending around objects, just like a ripple in a pond. But other times, it acts like a stream of tiny individual particles, like little bullets of energy hitting a target. These two behaviors are completely at odds with each other. So this was this huge puzzle for physics. How can it be both? How can something be a continuous spreading wave and a tiny self-contained particle at the same time? It just doesn't make sense. So which is it? And the answer, which comes from the absolutely bizarre world of quantum theory, is as mind-bending as it gets. Light isn't a wave, and it isn't a particle. It's somehow both at the same time. It only decides to show itself as one or the other, depending on how we try to measure it. Crazy, right? And isn't that just incredible? We started with a simple observation about a pencil in a glass of water, and we ended up at the very edge of quantum mechanics, questioning the nature of reality itself. It just goes to show that even the simplest things we see can lead to the deepest questions, revealing a universe that is so much stranger and more amazing than we can imagine. It really makes you wonder, what other rules are just out there waiting to be bent?